In this video, we will look at the behavior of monomial expressions for values of x between 0 and 1. So recall that a monomial expression is an expression of the form a times x to the n, where a is any constant value and n is any constant non-negative integer. So let's look at an example. So let's suppose that x is equal to 0.5. Then x to the power of 1 is just equal to 0.5. X squared is equal to 0.5 squared, which is equal to 0.25. X cubed is equal to 0.5 cubed, which is equal to 0.125. Finally, x to the fourth is equal to 0.5 to the fourth, which is equal to 0.0625. Now, as we move down this list, notice that each time all we're really doing is multiplying by 0.5. Because each increase of our exponent by 1 just means we multiply that value by 0.5 one more time. And anytime we multiply by 0.5, our value is cut in half. And so our new value should be smaller than the value that we started with. So anytime we multiply by a number less than 1, we expect to get a smaller number. And therefore, when we look at this exponentiation, or x to a power of something, if that value of x is less than 1, then each time our exponent increases by 1, we expect our power to get smaller and smaller. So we can actually generalize this. For any values of x, so for values of x between 0 and 1, x to the m is actually less than x to the n if m is greater than n. So if we have a bigger exponent, so m is bigger than n, then x to the m is actually less than x to the n. And so between 0 and 1, larger exponents actually create smaller values. Let's take a look at this graphically. So here I have the graph of y equals x to a power of 1, which is just equal to y equals x. And I'm only showing positive values of x, but this graph could go on to the left as well. But we'll just look at values of x greater than 0. So now let's add y equals x squared. So we'll keep y equals x, and then we'll also add the graph of y equals x squared. And from x equals 0 to x equals 1, we notice that the output of x squared is actually less than the output of y equals x. So this graph is actually, for each value of x, the y value on this x squared graph is less than the y value on the y equals x graph. Now let's keep those two graphs and then add y equals x cubed. So if we throw that graph on there as well, we again notice that for any value of x, y equals x cubed is actually going to be less than the corresponding value of x squared, which is less than the value of x. We could continue adding these powers of x, or add the graphs corresponding to those powers of x. And between 0 and 1, as our power gets larger, our output is actually getting smaller. And that again stems from the fact that when you multiply by a number less than 1, your value should be getting smaller.